Katherine, can you hear me?
Yes, I can hear you.
Okay, so I'm just changing the language here. So probably I will start with a little introduction of yourself. And after that, the stage is yours, okay? Is it okay? Okay,
Yes, that's perfect.
if you have any slide deck to share with us, you can do that right now.
Okay, I can share the screen via my nearby tablet as well, or you want me to send the file?
No, you can share from your computer.
Okay, perfect.
Okay, perfect. So Lapa City Tiantong, aka Katherine, is a highly skilled systems assurance manager with 9 years of international RANS engineering experience in railway projects. With a background in telecommunication engineering and statistics, she blends technical expertise and analytical skills. Known for managing more than 25 projects and adapting to change while achieving goals, Lapa City volunteers as a Deputy Assistant Director for Outreach at INCO's Outreach and a committee member of INCO's Thailand chapter. Selected as an exclusive delegate to represent Thailand in the Universal Youth Leadership Summit in 23. Passionate about engineering, professional growth, and leadership. Today, she'll talk with us about the truth or myth in systems engineering in railway industry. So the stage is yours. Be welcome in your conference.
Okay, thank you, Diego. Thank you for having me. Hello, everyone. I am delighted to be here today to talk to you about true or myth system engineering in the railway industry. As for the introduction, my name is Lapasili. I'm also going by Katherine. I'm a system assurance manager at ST Engineering Urban Solutions. ST Engineering Urban Solutions specialize in designing and providing solutions for the railway industry. The range of products include platform screen door, automatic bag collections, telecommunication system, and SCADAs. Their solutions are aimed at enhancing safety, efficiency, and overall passenger experiences in railway networks. I am in charge of system assurance and system engineering, which include reliability engineering, safety engineering, requirement management, technical planning, and etc. I have 9 years of experiences in railway industry, working on various international projects. And additionally, I am serving as Deputy Assistant Director for the INCOSAT Outreach team, one of the committee members of INCOSAT Thailand chapter, and also one of the International Advisory Committee for Global Youth Development and Empowerment in INCOSAT. If you would like to connect with me after this event, you can find me on LinkedIn. You can scan the QR code or feel free to reach out via email. Before we dive into the myths about system engineering in the railway industry, I would like to talk about the reasons why I chose this topic. I have two main reasons. Firstly, I have had a privilege to engage in conversation with people from all walks of life, colleagues, customers, friends, individuals outside the railway industry, and even strangers I have met. Generally, when people learn that I work in the railway industry, their eyes light up and they are eager to learn more about it from an insider's perspective. And more often than not, their questions revolve around system engineering. They are curious about what goes into making trains run safely, reliably, and efficiently. And it's making sense as all of us know that railways are a fundamental mode of transportation that has been around for centuries. It's a big part of our life, We use them to get places, from daily commutes on metro trains to long-distance travels. I believe that most people have experienced train travel at least once in their life, and sometimes railway is also the destination to take cool pictures. And since railways have been around for so long, it's natural that people have opinions about them, especially when something goes wrong. From social media discussions to news headlines, there's no shortage of commentary surrounding railways operation. I have encountered situations where individuals from diverse backgrounds have expressed genuine interest in the effectiveness of system engineering practices within railway systems, especially in reliability and safety engineering. They may not use the exact terminology that we are using in our communities, but I understand that their concerns are from a desire to understand the underlying principles that keep our levels running safely and reliably. Secondly, I usually get excited when I meet individuals who work in system engineering across various industries. Every time I listen to system engineering experiences stories from professionals working in other industry, their story usually amaze me. Despite the common concept and objectives that underpin system engineering across different domains, there are noticeable differences in approaches, processes, arrangement, and the way people do things. I find this difference to be both beautiful and interesting, and I believe that sharing and exchanging insights with fellow system engineers can lead to mutually beneficial outcomes, whether it's gaining new perspective, refining existing practices, or simply enjoying a delightful journey of shared insights and perhaps some deja vu moments. And that's where I start. So I have done some research on system engineering in the railway industry, and I have identified 10 common words related to this field that I would like to explore with you today. However, before I proceed, I would like to ask the audience a question. What are some of the words or phrases that come to mind when you think of system engineering in the railway industry? And as we dive into this meet, I encourage you to actively participate by asking questions and sharing your own experiences in the chat. Your engagement will enrich this discussion and make it more meaningful for everyone. And we will look at them later during the Q&A session if the time allows us to do so. I'm happy to discuss any topic further. So now let's start on this journey to unravel the truth and myths surrounding system engineering in the railway industry. The very first one is system engineering in the railway industry is fundamentally an engineering discipline focused on the development and management of railway systems. The answer is it's a myth. And I would say this might be one of the common misunderstanding of the definition of system engineering. Many think railway system engineering is only about handling trains and installing railway system, but it's much more than that. So maybe the common question is what exactly is system engineering? Based on the NCASE definition, ISO 15288 and System Engineering Book of Knowledge website, is a transdisciplinary and integrated approach that enable the successful realization, use, and retirement of engineered systems using system principles and concepts and scientific, technological, and management methods. Importantly, successful systems must satisfy the needs of their customer, user, and other stakeholders. To ensure that systems as a whole meet its intended purpose, system engineering utilize a wide range of disciplines, including engineering, operation, maintenance, human resources, finance, and etc. The key activities are like develop understanding the needs and expectation of stakeholders, like from all relevant stakeholders. such as operators, government agencies. This may be vary from different projects as well. Secondly, like defining the system requirements, aka managing requirements, requirement engineering, or requirement management. So we need to translate the stakeholder needs into the clear and concise system requirements. And we also need to get the approval from customer, like get the confirmation that we have translate requirements in the right way. And these requirements gonna be the foundation for the design and development process at the further stage. Next, we also need to consider about integrating system component into assembly, into subsystem, into the system, and into the railway network. And we need to ensure that all of them work together seamlessly to achieve the desired system behavior and outcome that the customer wants. And of course, we also need to consider about verifying and validating the systems, V&V managements, ensure that it meets all of its requirements and is performed as intended. Lastly, we also need to consider deploying and maintaining the system, like oversee the deployment, maintenance of the system. Do we have any specific safety requirements that we have derived during the risk assessment and other activities, other system engineering activity that we have performed in the project? These are the key activity that I have picked, but we also have other system engineering activities that we need to perform in railway project, which may vary in each project. So system engineering is not just like building complex system. It's about ensuring that system meet the needs of stakeholders, operate safely and reliability, meet all its intended objectives, and we need to ensure that everything working fine as well. The next item is system engineering is a critical discipline for the safe and reliable operation of railway system. This one is true. Part of system engineering includes specialty engineering called safety and reliability engineering. Within the railway industry, there exists an international standard known as EN 50126, which is practically considered as a requirement for all railway projects. This standard outlines the RAM's reliability, availability, maintainability, and safety process requirements, emphasizing the necessity of proper system engineering as its foundation. So system engineering is a key player in every railway project. Now, I would like to move on to the next item. System engineering efforts are the same in our railway project. This is also another myth. I think tailoring is the key. Large projects require different depths of effort and focus. Large and complex project is going to require more effort than simple and a small one. Even two similar sizes of projects can have major differences in system engineering efforts sometimes. Like, for example, if one is considered as safety critical, but another one isn't, the safety critical one will require a larger effort and more safety activities, and etc. Now, let's move on to the fourth item. System engineering in the railway industry is only necessary for large and complex projects. Well, it's also a myth. This is a very common one as well. This misconception may lead to the exclusion of system engineering from smaller scales and medium scale projects. And it could hinder their potential for success and create high risk in several aspects, such as cost creep, customer or operator might not accept the system or the project works. Obviously, system engineering is very valuable for large and complex projects. System engineering can be applied to projects of all sizes, from simple track maintenance, minor software upgrades, to the development of new high-speed rail lines or the development of groundbreaking rail networks. So even small railway projects can benefit from the discipline of systems engineering as well. We just need to tailor the system engineering effort and solutions to match with project characteristics such as size, risk, complexity, and so on. Sometimes a small or medium-sized project can be a high complexity project. We need to consider all the relevant factors before we justify the effort and proceed. For example, a project concerning a few changes in software in a railway system, which resulted in changes in train speed to be increased around 5 km per hour. The change seems small, but consider the area track curve, exiting speed limit, and etc. Maybe we also need to ask the question like, have this kind of changes ever been implemented before? If not, maybe it's not a significant change. But if it's a yes, like twice or triples, so it sums up to be like speed is going to be increased around 15 km per hour or 20 km per hour. That is going to be a significant change and complex, even the project size is small. So for this case, we cannot simply say it's a small change. For the real, like the real small project, we also need to identify risks and provide a proper system engineering solution. Therefore, it's applicable across all project sizes and is enhancing efficiency and safety as well as ensuring that requirements are met and costs are optimized. Now let's move on to the next item. System engineering is too expensive and time-consuming. It's a myth. While system engineering does require an investment of time and resources, it can actually save money and time. System engineering can help us to avoid costly delays, rework, potential disasters, and costly mistakes by identifying and mitigating risks early on. The way that it can help us avoid cost creeps because of the way system engineering allows people who are working the project see what are the requirements we need to comply. So we can know what we should do. We are not overly committed to deliver something no one wants or overlook some required functions or capability. And then we need to rework all of that things. So in addition, it also like eliminates some hassle and reap some kind of return on investments over time. The next item is system engineering in the railway industry is not a one-time activities. System engineering work or tasks require an iterative and repetition process throughout the project life cycles. This one is true. It's iterative and it should be applied throughout the entire project life cycle. Maybe this also apply to, I believe that this apply to other industry as well. Some people might think that it's just a one-time activity and some may say that it's not a one-time. So it's not a one-time for sure. And then we need to constantly being like, on the system engineering artifact are considered as lived documents. And if any changes are made in control, we also need to monitor the system and the system engineering documents. If any change are made, we need to make them in a control and managed way. So let's move to the next item. System engineering documents are just copy and pass from previous railway project that using the same product or railway system, this one is a myth. There are some part of document that may be reusable, but so many parts on factors are needed to be taken into consideration. Like, for example, on-site system testing activities need to be performed in each project. The evidence and outcome should be provided as evidence for requirement management and V&V management process as well. So it's not the same and cannot just simply copy and paste. Moreover, each railway project is unique, and so are its system engineering documents and artifacts. So while prior experiences can provide like valuable insights, a tailored approach is also essential to ensure that the specific requirements and challenges of each project are reasonably and practically addressed. Item number 8, system engineering is only for new projects. This one is a myth. System engineering shall be applied in both greenfield projects and brownfield projects, whether it's simple upgrades or reconditioning projects, or maybe like a complete reconditioning systems and etc. For brownfield projects, we need to consider what changes we are going to make to existing systems, how changes are going to be managed, any risks, how new system or equipment will interact with these existing ones. What are the stakeholder needs for this upgrade project? Everything I have just mentioned is part of the system engineering activities. So yes, we need system engineering in brownfield projects. Now let's move on to the item number 9. System engineering is non-existent in several projects, especially in countries without laws or regulations mandating its implementation, such as Thailand. Is a myth. I have heard so many people talk about this with a strong confidence, and even see them post about this matter on social media. Based on my professional experiences in railway project in Thailand and some other countries that also have no specific railway laws and regulations, all of them require the contractors to follow international standards like EN 50126 and also ISO 15288 in some projects. In all projects, the railway operator or railway owner will employ a third party. They may be called consultant or independent certification engineer, or maybe they may be called other name as well. However, these people will be hired to verify the compliance of contractors with system engineering artifacts are playing vital roles in these inspections and verification. So the importance of this system engineering discipline is widely recognized and implemented practically even with no law enforcement or regulation in place. International standards such as EN 50126 provide a robust framework for implementing RAMs and system engineering practices in railway projects worldwide. Now let's move on to the last item. System engineering is only for large companies. It's also a myth. The benefits of system engineering are not limited to large organizations. Companies of all sizes can gain benefits of this discipline by implementing system engineering principles in a way that align with their resources and capabilities. I believe that if the system engineering process has been applied properly in small and medium-sized companies, it could make significant impacts. For example, it could help optimize costs, decrease cost creep, and improve the operation, enabling company growth, and etc. I think the key is proper tailoring tools and methods. And that's cover all the myths I have prepared to share with you today. Now, I would like to give a moment to the INCOSET Thailand chapter. NCOSE Thailand chapter is a newly established chapter. Recently, we have transitioned from a startup chapter to an emerging chapter. I hope we will continue to grow in the months and years to come. Our members are a diverse group of people with unique knowledge and experiences in system engineering, and they are actively sharing their unique knowledge and experiences. We are currently working on establishing working groups and initiatives that will address the need of our members and the system engineering communities in Thailand. Here is our LinkedIn page. I hope it can be a source that help us easily connect with each other in the future. We are open to collaboration activities such as joint webinars, meetings, and etc. If you have any ideas for collaboration, please feel free to connect with us through our LinkedIn page or directly message me. So is to wrap up our talk today. System engineering is like a roadmap for handling on the complicated parts of railway system and project management. I hope it's not wrong to say to simplify it in this way, but I believe that it helps us spot and fix problems, follow requirements and regulations, make things work better and more. Without using system engineering in the right way, railway projects might take longer and cost more than they should. The myths we talk about today can be both challenges and opportunities. I believe that some of these myths are unique to the railway industry, but they may happen across various sectors as well. I usually explain system engineering concepts to my colleague and people in general by saying is entering our perspective, managing our project, and systems from different angles, like putting together a jigsaw puzzle like this. When we see things from different sides and put them together, it makes a full and beautiful, complete picture. System engineering doesn't only help us get the right project outcome that align with stakeholder needs, it's also about making railway system work together well with our understanding of how things should be, so it's work well. Like it's work safely, efficiently, and well together. Let's say it that way. So using system engineering right means blending different ideas, disciplines, and talents to create something amazing. And to sum it up, as Kelly stylingly said, when different worlds collide, spectacular things can happen. I believe that system engineering is the glue that brings different ideas and systems together, making our railways safer and better. Back to you. Thank you for listening, for your attention, and thank you for having me here today. Back to you, Dago.
Okay, thank you, Katherine. Thank you for your presentation. Very insightful. I would like to ask you one question. One of the process in the systems engineering that I consider the most important is the tailoring process, especially when we are considering, like you said in your presentation, like small companies, different countries. So my question is how systems engineering can be tailored based on your experience?
So it's like we have to consider all the factors and the requirement from customer. We need to find what is the expectation of stakeholder. Sometimes it's not stays so clear in the contract. So we need to have a meeting with customer, find the real stakeholder needs, consider the engineering practice, international standards, and then find a conclusion and agreement between stakeholders and relevant parties.
Yeah. Oh, thank you. We have a question here from our audience. It's from Adayu. Thanks for your question, Adail. The question is, how is your experience with other transport modes like metro and light rail, for example?
Metro and light rail. I don't have the experience with light rails, but I have the experiences in metro. So most of the metro will adopt CBTC, but sometimes it's adopt ETCS level 2. So I mentioned this because it's linked to different technologies. We also need to use the system engineering as basis. And when it's metro project and it's linked to several people, general public usually interested in the project as well. So we like having a very tight deadlines. We having like more constraints and more pressures. But so most of the metro project, they're gonna require the full system engineering process as usual. So I would say most of them require system engineering to be implemented. Yes.
Thank you, Katherine. Congratulations on your presentation. First of all, we have here a question from Bruno Bacci. Thank you, Breno. I'm sorry for your question. Thank you. So he says, "Hi, Katherine et al. And all. I would like to know what's the state of INCOSE development in Thailand. Do they have a INCOSE chapter there?"
Yeah, we have an emerging Thailand chapters. So we have just started for a while and we are open to collaboration. Please feel free to DM me or DM our INCOSE Thailand chapter page. So we are hoping to see more collaboration activities and all of you are welcome.
Thank you. Thank you very much.
Thank you. I hope that's just the beginning of a fruitful collaboration between Brazil and Thailand. Hopefully, we will be at some point present in your conference, something like that. We hope, and we hope you enjoyed to be here with us today. We know that it's very early, so thank you for that. So, if you have to send a final message for our audience.
I would like to say that thank you for having me and thank you for the warm welcome and the questions that that lead to very nice discussions. So thank you so much and thank you for joining today as well.